Hi, I'm Paul from Cryodynamics International. I'm joined today by Fotis from the University of Strathclyde, and we're working together on the SafePASS project, looking at evacuation modelling tools and how we can really progress them to help in keeping passengers safe on board cruise ships. So at the moment, evacuation models are typically computer simulations. They're used to forecast how passengers move during emergencies, and they're typically used in design stages. So they help to determine whether a cruise ship design is safe, whether it complies to maritime regulations, and to show what sort of congestion might be expected when the ship is actually evacuating. Now in SafePASS, we're trying to take that way beyond doing it for the design stages and run it actually during an emergency on board the vessel. So we'll take in information from the vessel and therefore be able to optimize the evacuation time depending on the situation that's actually happening. So we'll start with what we can do with evacuation models in terms of having a cruise ship geometry, knowing where the muster stations are, modeling all the phases of evacuation. And that will be done for any cruise ship, but then that will be changed based on who is actually on the cruise ship on a particular journey, the incident that's occurring at the time and the movement of the ship. And therefore we can actually optimize or minimize the evacuation time by showing people exactly where to go rather than letting them find their own way. So I'll pass over to Fotis now to describe some of the evacuation modeling.
Thank you, Paul, and good afternoon, everybody. My section on this presentation is dedicated to the Evacuability Index software, EVI, by Brooks Bell, which is one of the very few tools that we have in our disposal in the maritime industry when trying to assess the evacuation performance of a vessel against the regulatory requirements by IMO. With regards to advanced evacuation analysis on ships, EVI is a software of unique capabilities, primarily because of its ability to model complex scenarios and capture the impact in evacuation performance due to events, for instance, like blocked routes due to fire and/or flooding. Within the context of SafePASS, where our focus is on extreme flooding and fire scenarios, you can understand that this element of the software is crucial. With EVI, we have the ability to identify critical evacuation-related scenarios and examine risk mitigation measures. At large, these capabilities arise from the agent-based modeling nature of the software, which allows for the customization of testing scenarios by changing the objectives of agents and the accessibility of spaces or routes by closing or opening doors. In SafePASS, EVI has multiple uses. It is initially being used to benchmark specific scenarios, and it will later on also assist in the verification of the results of the cryodynamics evacuation simulations. In the meantime, a series of accident flooding simulations are being carried out, the outputs of which, in terms of ship motions and flooded areas, will be fed into EVI with the purpose of assessing the available time to evacuate and calculating the number of potential fatalities. So, EVI is also playing a key role on the development of the dynamic risk model of the project, which will serve as a real-time decision support system. I hope you enjoyed this brief introduction on EVI's capabilities and use within our project. I now leave you back to Paul.
Thanks. Let's look at how this can be adapted into real-time simulation on board the ship and how that changes some of the evacuation strategies potentially. So as we said, bear in mind that we're taking data that will be provided by the ship itself from ship sensors and different sensors that we might install as part of the system. And we'll then make predictions based on the crisis that's unfolding, the fire and the flood as it potentially spreads through the vessel. And the evacuation models themselves will then look at the passenger movement, but do it in real time. So we'll be calculating the safest route for passengers automatically based on the data that's available, avoiding the areas where there's smoke, fire, or flooding, and also areas that are particularly affected by ship movement. And that can also be done on a per passenger basis if we have the information about the passenger. For example, if they have mobility impairment, they may have to take different routes to the passengers that don't have that mobility impairment. So what you see as the background actually here is a piece of software that we use to create the crowd simulations, and they're calibrated. So we take the geometry of the ship and look at how people actually move in the evacuation, different evacuation strategies, and we test lots of different scenarios before this simulation is then put on the ship to run automatically. So it's all calibrated beforehand. And then when we get data in as to what's actually going on and who's on the ship and how they move, we can then model that actually on the ship, looking at a variety of different types of evacuation and evacuation strategies. We can take information on how routes are blocked. So if there's no sensor data, but the bridge or a crew member reports that actually a route is blocked, that can be input live, and that will be taken into account in the simulations. Now, these models are run extremely quickly. So in only a few seconds, you can get information about what's happening over the next hour during the evacuation. And that is brand new situational awareness that is not available at the moment. So it's specific to what's happening. It's a forecast of the congestion so that the bridge knows that certain areas may become congested due to the situation that's happening, and it'll optimize those routes for passengers and communicate it back to them. So because it runs so quickly, it's all done in the background, and then the common operational picture that's presenting what's happening right now will also have a prediction of what's going to happen in the future. So this is a fairly complicated block diagram of the overall system, but basically in the bottom part, there is the evacuation modeling, and that's taking all the fire flood orientation data, using all the calibrated models to calculate what's going on. And that's fed back into the main Evacuate core system. And in this part in the middle, there's all the sensor data that's being processed, communicated back to the simulations to use. And that will be constantly updated. So it's not just based on one prediction at the start that may be slightly inaccurate. As the evacuation goes on and more data is available on where people are and how they're moving, it actually updates. So it's an intelligent and iterative simulation that happens to constantly give a more and more correct picture of what's happening. Now, the initial prediction should be pretty good and will be good enough to base decisions on and to guide people in the evacuation, but other things can happen. There's never an absolute as to what's going to be going on with the fire or the flood or overcrowding, or somebody's passed out and blocked a route and therefore the whole routes need updating. But that can then be accounted for because it's running again and again through a loop and providing updated information. Now, the standard thing that will happen is that the original prediction will be correct, and that there'll be little changes to it. So it's not like it's constantly sending people one way or another way. That there'll be a limit to how many changes are actually made in that, but it can take into account major things that need to be accounted for that were unexpected when the simulation started. So in the top part is the other SafePASS systems, where the data on the routes and other information is passed to communicate it to the passengers and to the bridge. Now, because we've got this system in place that can optimize the evacuation as it's actually happening, you can change how the more traditional evacuation strategy works on a ship. And this is probably one of the most innovative things. It would currently go against the IMO regulations, but the IMO regulations don't take into account the fact that these advanced simulations are now possible. So these 5 sort of evacuation strategies are for different situations, but the top 2 are the more traditional ones, and then 3 and 4 are the what's now possible. And evacuation in port obviously can exist now, but it's less focused on in the IMO regulations, and actually is a potentially one of the highest risks if you were to evacuate from a crowd congestion point of view. So the system can also help that. So we're going to focus on the first 4 rather than the port evacuation, but essentially what happens at the moment, generally older ships have the life jackets in the cabins, so everyone has to go back to their cabins. Then they make their way through a fixed route to their muster station, and they'll have practiced this during the drill. But it takes a long time, like 60 to 80 minutes for the overall process of evacuation from the regulations. Now, a stadium has generally got to evacuate in less than 8 minutes, and a building has got to evacuate to a safe route usually in less than 3 minutes. So if you compare what's the risk to people in those situations, there's seemingly no reason why the cruise ship should be the longer time, apart from the fact that it actually takes that amount of time to go through the evacuation process. Now, various things have reduced that time on modern ships. One of the main ones being just locating the life jackets in the muster stations, which speeds everything up because there's not the journey back to the cabin. But there are some things that still happen in this. So the example I've put there with the theatre is, if the theatre is a muster station, then you've got a lot of people in the theatre potentially. An evacuation happens. Most of those people then leave to go to either to their cabins or directly to an allocated muster station, their fixed muster station. And then a load more people come back into the theatre and fill it, which, even though one example, there's sort of an obvious way to optimize that the people in the theatre should stay in a safe place in the muster station and get their life jacket there. So the thing is, to be able to facilitate that needs the system, because you have to communicate where people are supposed to be going, and you have to calculate who should go to which muster station. But that's what the system can do. So from the incident and gathering the sensor data and doing the modeling and optimizing the strategy, you can actually allocate people in different areas to a specific muster station. So in the theatre example, you can say, well, everyone in the theatre stays in the theatre and just puts their life jacket on, and that the mustering process is then already done. And elsewhere around the ship, people would be directed to a suitable muster station. So it's not necessarily their nearest one, but the default would be to send to the nearest one. We can't overload the muster stations, but the system is intelligent enough to be able to calculate that very quickly, to guide people, to distribute them around the ship as to what is best for the overall evacuation. So we can dramatically reduce the time. And in really life-threatening situations where there's an incident that's going to dictate that actually mustering and then going to lifeboats would take too long. So it's a pretty severe incident, but it is possible for the system to then calculate sending people directly to embarkation stations ready to go onto lifeboats. So there's a brand new, and there's pros and cons to different things of this, but what our research is showing is that the system enables this type of evacuation. So it's a whole different strategy, and one that's very dynamic depending on the situation, but that can reduce the actual time to evacuate, reduce congestion during the evacuation, and get people into those safe places much quicker. I really hope you've enjoyed this presentation on evacuation modeling on cruise ships, and hopefully it's provoked some thought as to how evacuation strategies could change aboard ships.